web map services, which effectively takes a picture of the image that you're interested in. So let's say it's a satellite image. Let's change and say it's Landsat. So it'd be a Landsat image of, say, Denmark, and you can make a web map service request, and you get back a picture of that image. So it's like a snapshot.
Hello and welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Dr. Alistair Graham, and we're going to be talking about Earth observation and remote sensing. Even if you're not a remote sensing Earth observation scientist, I think you're going to enjoy this episode. We start off nice and gently. We give a few definitions of the difference. So we talk about the difference between Earth observation and remote sensing. We move on to talk about platforms and data and take it from there. Just before we get into the interview today, I want to take a few moments here just to thank our sponsor, GraphHopper. So GraphHopper are the creators behind a super fast routing optimization engine. So this is a directions API that you can build your own application on top of. And the problem that they're solving is often referred to as the traveling salesman problem. So given a list of locations, what is the optimal route that visits each location and returns to the starting point? So GraphHopper is doing this for multiple vehicles of different profiles, different types. So if you're interested, you can get a basic idea of the service GraphHopper provides by going to graphhopper.com/maps and yeah, there's a little web interface there that you can play around. You can see how fast it is, and it's actually quite interesting. Or if you really want to get your hands dirty, you can go and check out their routing engine on GitHub, which they've released under the Apache license. So thank you, GraphHopper. I really appreciate your support. Hey Alistair, welcome to the show. Thanks for coming back. The first episode we recorded together was called Remote Sensing and the Future of Earth Observation. So that should give the audience a little bit of an idea of what we're going to be talking about today, which is, of course, Earth observation. And you are actually Dr. Alistair Graham. So you have a PhD in this. Before we dive into the conversation, perhaps you could just remind the audience what your PhD is in and perhaps set the scene a little bit about your involvement with Earth observation remote sensing.
Hi there. Thanks very much for having me back on your podcast. It's great to be here again. My PhD was basically looking at irrigation. That's the sort of official, really important one. But the much more highly amusing explanation of what I was doing is I was looking at potatoes using radar from space. So this is back in the late 90s, and I was using ERS-2 radar data. Basically was looking at a series of different potato fields, trying to look at canopy and soil moisture and model those, and then work out whether or not the crop needed irrigation, because it's a very water-hungry crop. There was a whole series of modeling exercises and data processing exercises that went into that PhD. Unfortunately, the irrigation side of things didn't actually happen because my PhD happened to coincide with the 3 wettest summers in the previous 10 years. So there was absolutely no need to irrigate the crop. But on the science side, everything went perfectly well. So that was great. And then since then, I've basically been working in the EO sector, and you can listen to the previous episode to find out sort of a bit more about me, I guess.
Yeah, and of course there'll be an opportunity towards the end of the show where we mention where people can go to get a hold of you. So that'll be there too. You're not getting off the hook that easy. You talked about potato modeling there. Now, I understand that there was a lot of other really interesting processes and challenges involved with that, but what problem were you trying to solve with potatoes? Was there a problem at the time? Why was Earth observation a good tool for that?
Yeah, so there were a couple of issues. So one was, both were linked to environmental issues. One was just the use of resources. So in the UK, which is where my study site was, potatoes are grown in an area that has very good soils, but unfortunately it's a very dry climate, and therefore a lot of water is sucked out of the rivers and the groundwater. And what they wanted, what the purpose of the research was to try and understand if you could monitor the potato crop using radar, and then more intelligently apply irrigation waters to the crop. And then the second one was that what had the Environment Agency, the body in charge of policing effectively the abstraction of water for use in agriculture and other uses, had found that in previous drier summers, a lot of growers were actually abstracting water when they needed it, which was outside of the license agreement that they had, and therefore it was technically an illegal abstraction. And this meant that sometimes there wouldn't be enough water left for those growers who were adhering to the license conditions, and so they weren't able to irrigate their crop when they needed to. So another part of the project was if we could demonstrate that you could monitor water usage and the provision of irrigation onto a crop in sort of real time, bearing in mind we were using monthly radar data, then it would be a way of trying to stop people just abstracting water whenever they want. Effectively, you could say, like, we can see you from space, so don't break your license agreements. And today, I mean, I would love to go back and redo that PhD today with the Sentinel-1 data set that we have. It would be absolutely amazing to have this huge, temporally rich data set over the whole growing season and see exactly how it could be done. So I haven't really kept up with the radar and potatoes part of my life, but I would be really interested in knowing whether or not this is something that people are still interested in, and whether they want to try and take that forward, because I thought it was a really neat little application at the time, using radar data for that crop, for that specific thing of looking at irrigation and water use. And technically, it's more tricky than you think.
Yeah, I can imagine it is. But what I'm thinking is a film. I'm thinking there's a story in there about potato modeling. We've got police, we've got potential corruption, and all of it being, remotely monitored from space. So I don't think you should focus on the PhD angle. I think you should go pitch this idea to Disney.
Oh yeah. I'm liking that. I can see that. Maybe The Rock should play my character. I think that would be quite good.
I've never met you in person, but I don't know.
Very similar. Very similar.
Okay, I'll take your word for it. Great. Okay, so we've set the scene, I hope, for the listeners. We're going to be talking about Earth observation, remote sensing. Let's have a bit of a definition about these things first. Firstly, Earth observation, for me, that was always remote sensing in the past. Are they two different things, or is this the new name for remote sensing? Is there any difference between either of those things?
Yeah, so in my mind, being a little bit pedantic, there is a difference between the two. So using the Wikipedia definition of Earth observation, it's basically the gathering of information about the physical, chemical, and biological systems of the planet. So that can be via remote sensing technologies, but it's a little bit more than remote sensing. So remote sensing, you don't actually physically touch or interact with the thing that you're monitoring, i.e. it's remote. But if you're looking at Earth observation, you can include things like wind gauges and thermometers and ocean buoys and that sort of thing. So you're physically in the medium that you're measuring, but it's being used to observe the Earth system process overall. So that's the difference. But I mean, in terms of day-to-day discussions, usually the two are interchangeable, and Earth observation is generally used to talk about either satellite or aerial or drone imagery and that sort of thing. But there is a little bit more to it. That's just the thing I'd like to get in people's heads.
Appreciate the clarification. And you will have to forgive me if I mix the two up a little bit during this conversation. It's still stuck in my mind that everything is remote sensing, but you please just forgive me on that one. Be a little bit patient.
I'll do the same, so no worries.
Okay, so one of the things that really fascinated me about remote sensing when I was doing my master's at university was the process of defining and testing pixel signatures and creating accurate classifications. And that was all a really, really interesting challenge. But I was also doing some GIS courses, and it occurred to me that remote sensing was a huge, and potentially still is, a massive part of this sort of data manufacturing pipeline. So a lot of the products that come out of remote sensing, Earth observation, are used in other places. So we go from, at least in my mind, we go from continuous data to discrete data. Is remote sensing, is it still playing the same role in terms of data generation as what it was in the past? Or are we seeing other ways of collecting data? Can we jump over that process now? Can we go straight to collecting discrete data?
Yeah, there's quite a bit to unpack there. I mean, basically, the whole of the Earth observation / remote sensing side of things has changed so much in recent years. I mean, and by recent, I mean sort of like the last 5 years, really, in terms of how much data is available. We're now almost awash with the amount of data that we can capture. And there's a lot more systems coming on board over the next few years as well that will capture even more. So I guess really the important thing now is not necessarily to think in terms of remote sensing or GIS. And I know a lot of people do, like probably the majority of people do, even within the sector itself, that these are two distinct things. But actually, really, what we're doing is we're geospatial data scientists now. And so being able to understand how to capture data. I mean, you might not necessarily be the person involved in doing the data capture, but understanding the processes involved in data capture, then the pre-processing, the provision of those data out to different software systems, and how those can be then used to process the data away from continuous data into discrete, it's all part really of the new, what sometimes gets termed the Earth data science or the geospatial data science modality that we've got really around the whole sector. So yeah, I would say that we're not getting away from one or other. I think in a way what we're seeing is an amalgamation of all of the different technologies in order to create whatever it is that is required as the end product.
Thanks for that. I think that's a really important thing that you said there, and I think it's also really important for people like myself to get away from thinking of remote sensing, Earth observation, and GIS as being different things. They require different skill sets, but I mean they're really, really interconnected. And it's important to understand both sides of it. I think if you're doing remote sensing, it's important to understand, okay, where are these products that I'm deriving, these data that I'm deriving, where are they going to be used? How are they going to be used? And vice versa. If you're on the other side, okay, well, where did this come from? What might have been the problems making this? Why does it look like that? I think those understandings are incredibly important on both sides.
Yeah, I think a good way to look at it is to think about what's happening in terms of, say, web apps or mobile apps. And I admit that I don't have a lot of experience in those, but you don't necessarily break everyone down into silos and keep them there. You use your systems engineer, your systems architect, your web app developer, your DevOps manager. You use all those different roles in developing and creating and supplying a single output for whatever reason that you want to do that. And I think that's where we need to think of ourselves in terms of what we're doing with Earth observation and GIS. I think for too long we've sort of stood on opposite sides of the conference room and looked at each other and gone like, well, I can't talk to them because they're not doing raster or they're not doing vector or whatever. And really now we should be beyond that. We need to make sure that we're all using the correct types of data and the correct types of technology in order to get to a much more coherent endpoint, which is going to be whatever the client or the application requires.
So my hope was, with this line of questioning at the start, with that question about the definition between or the difference, between Earth observation, remote sensing, and this question about how is data being used. My hope was that was to kind of set the scene a little bit for what we're going to be talking about, and I really hope we haven't confused people with that. But my intentions were good. Let me say it like that. Okay, so I want to talk about Earth observation data sources now. And I know from a previous conversation that you've got this sort of clear list in your mind of 4 different sources that we should be thinking about. Of course, there are others, but could you run us through those 4 different sources of data?
Yeah, I suppose if I run from the highest altitude to the lowest altitude, and that might be a good way of doing it. So at the highest altitude, we have satellites and everything that encompasses. So they obviously can either be orbiting around the globe or they can be geostationary, which means they sit over a single point, but they basically collect data from space, inverted commas. The next lowest band of data capture platforms that I think of is aerial. And so that could be basically your camera inside an aircraft. And again, those aircraft can be flying at all sorts of different heights and collecting data over different spatial coverages, depending on what it is that they need to be capturing information for. Then closer to the ground again, you have your UAVs and your drones. They're sort of the new technology, inverted commas again, because they've been around for quite some time now, but they're becoming quite well established as a way of collecting geospatial data. But they have a sort of separate niche away from aerial data. And then I suppose right down on the ground or in the water is your in situ measurements. So this is something that isn't necessarily remote sensing, but it is Earth observation. So this is ocean buoys, as I mentioned before, is a really good example where you might have a thermometer or a saline meter or something in the water itself, and that buoy stays at a specific point and measures some parameter in the water as the water passes it. So those are my four different types of EO data source, and I accept that there are others, like you said, that fit in around those, but those four probably the sort of the big ones.
So if we leave out in situ for a second here, these other three sources, if we talk about satellites, aerial, and UAV drones, are there sensors out there in the world that can only be used from satellite, or where it only makes sense to use them from satellite or aerial or drones? Or are we just talking about a difference in height with which the measurement is taken from? Can I use the same sensors on all of these different platforms?
Well, that's an interesting question, because so historically you might have the same sensor types, but probably not the exact same sensor. So you might have a radar, for example, going back to what I was talking about with my PhD. You could have a radar that was attached to an aircraft, and you could have it on a light aircraft or a sort of a larger aircraft that was going at a higher range, and you could collect imagery from that system. And then you could again have a radar on a satellite, such as ERS satellites or the Sentinel-1 satellites that we now have. They wouldn't necessarily be the exact same sensor system. They might be very closely related, but there would be a difference in size and power requirements and all of that sort of thing. And so you would optimize them for depending on where you were going to be taking your collection platform. Now that technologies are becoming smaller and lighter, I know that some of the technologies that you have that you can apply to drones can also be used in aerial systems. And I think, and I don't think I'm wrong in this, but I think they can also be attached into some of the small CubeSats that you get. So CubeSats are typically small clusters of small cubes that are 10 centimeters by 10 centimeters by 10 centimeters. And you usually get 3 of these in a row, and you use that as your satellite platform. And then you basically have power generation component to that, and also a gyro stabilization component, and then a sensor of some sort. And the benefit of having these small sats is that they're low costs, they're easy to develop, and they're easy to launch. And I think that now I think you can get sensors that will work at all of 3 of those different platform locations.
Yeah, because I think previously, if I had asked someone that question, they would have said no, because satellites are so big that they, and they have other power requirements. So the sensor payloads are quite different. Aerial is quite different from drones, simply because the platform was so much more powerful. We could put more heavier stuff on an aerial platform and fly around than what we could in a drone. But I can see that this sort of gap or this difference between the platforms shrinking, especially when you take CubeSats into consideration. So I think it's an interesting time in terms of what payloads we can put on these different platforms. Obviously, performance is different, but still, the fact that they're getting closer to each other is really interesting.
Yeah, it's really fascinating. LiDAR, basically pinging a laser off something, is another really good example, in that we now have LiDAR systems that can go onto drones, and we've obviously had LiDAR systems in aircraft for quite some time, and we've got really helpful, really usable LiDAR systems either on satellites or about to be launched onto satellites. And so there's that, like those systems now can start to join up, and I guarantee you there will be manufacturers out there somewhere who are trying to make LiDAR systems that will be able to go on all three, from the same components. So yeah, it's a really exciting time, I think, in terms of being able to capture new data from all of these different platforms.
Yeah, like you said, the fact that they're coming closer together in terms of the payloads, that this means that we'll be able to start, joining those data together. And I think this is the new gold rush, actually. I'd be really surprised if we're going to improve things so much more in terms of analysis that we can do just by putting more satellites into the sky. But the combination of satellites, aerial, and drones and other technologies, if you can, weave them together in terms of their data outputs, I think that's where the future lies, personally.
Yeah, I think it's an interesting one. So putting more satellites into the sky has its benefits, but it also has its drawbacks in terms of cluttering up the various different orbits. But I suppose that can be managed in some respect. But yeah, this whole notion of fusing data from different platform sources is a really interesting one. One that I find that is just being sort of really looked at in any detail. And I think it's going to become more and more important. One of the things that I find quite interesting around the whole satellite Earth observation, remote sensing sector is there are these two use cases. One is sort of collecting information on a global scale. And so that involves its own set of rules and standards and sort of data resolutions and everything else. But then a lot of very specific, site-specific project work also gets done. And for that, you sort of almost need a mix of satellite, aerial, and drone data. And it all comes down to cost, I guess, in the end, as to which ones you use. But I think with some of the processing techniques and some of the softwares that are around now, it's much easier to be able to drop in or maybe say start with a satellite time series data for a site that you're interested in looking at some parameter, and then if that's not giving you enough temporal fidelity, then you can start to drop in aerial surveys or drone data or whatever. So yeah, there's lots of really exciting things to look forward to, I would say, in the next 5 years at least.
So I'm really pleased that you talked about cost, because in just a minute I want to move off and talk about open data versus commercial data. But before I do that, can we go back to the statement you made about CubeSats just before? You talked about them moving in groups of 3. Why is that? Why 3?
So these small sats are built from cuboid components that are 10 centimeters by 10 centimeters by 10 centimeters. And so you would stick 3 of those together to create a small sat, if you see what I mean.
Okay, so 3 separate components that are put together to make one satellite.
Yeah, and so one might have the payload in, one might have the gyroscopic stabilizer in, and one might have the power component or whatever. So that's sort of like the smallest block that you can get, really. I mean, I'm sure there are people who could tell you about how you would then take multiples of those small sats and create what they call sort of flocks of satellites. So you'd have multiple satellites in order going around in a constellation to collect data over the Earth at different sort of times, or in order to create larger data sets than any individual small sat could create. So, for instance, Planet is a good example of doing this. Also, ICEYE, I think Capella Space as well, are also going to put up a constellation. So there are a lot of use cases where these smaller satellites are being used in combination to create some pretty interesting and very exciting new data sets.
So, still sticking with satellites here, and I promise we'll move off in just a second. But this idea of satellites working in combination and in pairs with each other is not new, at least not in my mind. Haven't we got 2 satellites, or I can't remember if it's 2 or 3? The Grace project, where they work in a pair and follow each other around, and they need to do that to be able to measure what they're measuring.
Yeah, there's quite a few larger satellites that are either paired up in order to measure information specifically from that, or they are able to generate improved data resolutions by using both satellites rather than just one of them. So Tandem X, I think, is a SAR mission where I think there's two different satellites involved in that as well. So, well, I suppose also you could look at the Sentinel satellites. I mean, they don't work together necessarily, but they collect exactly the same information from two different satellites, and therefore improves your repeat time back to a position on the ground, or improves the amount of coverage that you can get. And so, yeah, there's a lot of precedence for using satellites together. But I guess the thing that's different is that with these small sats, what we're looking at when we talk about a constellation is usually sort of many tens of satellites together, working together in order to collect the data that is required by the companies that have put them up there.
Okay, so we started off talking about, we started off with our definition of Earth observation remote sensing. We talked about the different data sources. The four that were really important for you were satellites, aerial, AV, UAV, drones, and in situ. And I think we've had a really good discussion around that. So thanks very much for that. I'd like to move off now and talk about data, because all these platforms produce data. That's what we're really interested in. And of course, you have your own consultancy, so you understand this better than others, that tension between open data and commercial data. Most of us in our mind have a list of pros and cons, but I'd be really interested to hear your thoughts around the pros and cons between open and commercial data.
I would say that my personal stance, I'm a big proponent of open data and open standards and open source software. So that's where I'm coming from, is I prefer that generally. But I also understand that proprietary and commercial software and data is required. So in my mind, open data is generally fairly easy to access. So it might not be super simple. You might need to go through an API or something, but it's usually easy to find and to download if that's what you want to do, and it's generally easy to understand what it is that you've got in front of you, because any information, if it's a good data provider, any information that is available about that data is usually published alongside it. So for instance, I know we always come back to the Sentinel programs, but there's a definite hub where you can go. There are multiple sort of other hubs that have been spawned off of that, but there's one central hub. You can go there, you can look around for the data, you can access the data really easily, and you can also get hold of all of the documentation about it, so you can understand the heritage and the lineage of those data sets.
I realize that Sentinel might be, well, I haven't had much to do with it, but I'm sure it's a very well organized project, and the data distribution sounds like it's very well organized, also in terms of its metadata. But I think the general consensus around open data is that it's a little bit more difficult to get to, and it's sometimes more difficult to understand what you're actually getting. I'm surprised to hear you say that your sort of experience with this is that it's more open in every way. So it's maybe a little bit harder to find or get a hold of to access in that way, but more open in terms of what am I actually getting? How is it documented? Yeah, I would have thought that would have been the more so with the commercial data.
So open data in terms of what we're talking about, which is satellite data, these aren't just enthusiasts providing data. So these are large government-backed organizations that are providing it. And so there's this entire structure behind them where there's been a lot of discussion, a lot of thought gone into how to provide the data in order for it to get used in the most effective way. There's not really a huge help desk component in the background. So although the people will help you with your queries, it's much better for organizations like that to put forward all of the information that you want and for you to find it. So I can only go by my experience, but my experience in recent years has been that accessing open satellite data, I can do it quicker. I can find exactly what I want. I can find out exactly what it is that data is showing me and how it's been processed and to what level and that type of thing. I know because it adheres to open standards as well, that it will open in the software that I want it to open. So from my perspective, and I accept that I'm coming at it as someone who knows what they want, but from my perspective, it is much easier than going to a commercial outfit and saying, right, well, I want this, please. And then they say, okay, well, give us an AOI and we'll give you a cost. And then you have to go back to the client and say, well, is this cost okay? And then you have to maybe change if it's not okay, then change the AOI to the area of interest that you're looking at, to a slightly smaller one, go back, negotiate. And you waste time doing all this negotiation. And okay, the data at the end might be better for what you're looking at, and it's worth that time and effort. But I just find, personally, I like to be in control of the process myself. And if the data and the metadata has been made openly available, I can make an informed decision for myself and for my client as to whether or not it's showing us what we need to see. And I don't have to have discussions about how much things might cost, and then the client doesn't have to have a whole load of internal wrangling about, can they afford that? Can they not afford it? So I think personally, open data gives me and my clients more freedom to do the things that they want to do and to get the answers that we're looking for.
Yeah, I think you raise some really, really good points there. Things I hadn't thought about. Obviously, the price is the price difference between open data and commercial data is restrictive in itself. But I'd honestly never thought about the time that might be involved. I mean, that also has a cost when you're trying to organize things and being cost effective, and any sort of time delay that inevitably adds to the price. So we talked a little bit about a couple of data portals, and I'll put links to those in the show notes. So we've got Earth Explorer and the Sentinel Hub. But I've also, on my list of things to talk about here, I've got things like dedicated search companies. What is that? How do they work?
So they are trying to take out some of the things I've just complained about, because like I say, I mean, there is a definite place for some of the really high resolution proprietary data or commercial data. And if that's what's needed in order to get an answer for a given problem, then you need to be able to access that. So being able to go to dedicated search companies, and two I can think of are Apollo Mapping, which I think is in the US, and Geocento, which is here in the UK. They take a lot of the stress out of the whole data search. So you can either just contact them and say, right, I need information on this area. Here's my AOI, send them a GeoJSON or something for these dates, and let them go off and they'll find the data that's most relevant, and they will come back to you with a price. And then it's a case of, right, I'm just dealing with the one company rather than having to go and do lots of searches around different places. Or quite often, I think both of these companies that I've mentioned do this. You can go onto their site and then upload your own AOI, and their system does a search in the background and gives you a list of potential data sets that might be of relevance, and you can choose those. So there are obviously way more search companies that do this, and I think really it's something that is a bit of a sticking point in the industry in terms of the whole data discoverability and ease of access on the commercial side. And so I think it's really good that companies like this exist to take the pain out of doing these commercial data searches, and you can get open data through them as well. So there's another one, just looking in my notes. So there's another company called Skywatch that I haven't looked at in enough detail to be able to talk to you about in any detail, but they also look as if they're trying to rapidly allow people to integrate Earth observation data into various applications that they might have. So the whole point of this really is that it's how can you get the data you need with the minimum amount of hassle.
Obviously, through my own work with GIS, I work as a GIS consultant or geospatial consultant. So data, there's always that tension there. When you get data, where do I find it? Is it well documented? How much does it cost? Can I continuously have access to it? Is it a one-time thing? So I appreciate the the market niche these dedicated search companies are trying to fill as well. Part of me hopes that Google is going to, do what it says. It's going to index everything in the world, and in the future we'll just be able to Google the data we want. That search engine will just take over, and it'll be interesting to see what happens there. I also appreciate the tension these dedicated search companies are trying to solve. I guess we see the same thing. Well, I see the same thing in almost every data portal I've tried to use. There's very few of them out there which are user friendly. I always feel like you're constricted in some way or lots of different ways. They're slow, they're clunky, I'm yet to have a really, really great experience with a data portal. I'm not a user interface designer, so I'm not the one to try and solve this problem. But if anyone's listening and has a good idea of how to solve it or a good example, I would love to hear from it. I'd like to move on the conversation now. So we've talked about platforms, we've talked about a few other concerns around open data, commercial data, where we get it from, how we find it, that kind of thing. What kind of data formats do we typically see in Earth observation? So off the top of my mind, I'm thinking GeoTIFF is there. I can imagine ECW would be among them, and I could also imagine web services. Is there anything else that you typically see when you download this data in terms of data format?
GeoTIFF is definitely the industry standard, and that's moving towards cloud optimized GeoTIFF, or COGS, which are internally tiled and compressed version of GeoTIFF, which is used on cloud infrastructures. And they have a lot of benefits in that you can just access the part of the larger image that you want to use. So that's certainly check out cloud optimized GeoTIFFs if you get the chance. JPEG 2000 is another format that's used quite a lot. It's used basically on the Sentinel data provision side. ECW, as you've mentioned, is one of the proprietary data formats that is used, and that's been around quite a long time, but it is so good at compressing the imagery in order to allow it to be moved around, because obviously these images can be quite large, given that they have such high spatial resolutions these days. So ECW is a very useful data format to use, although I find it a little frustrating sometimes because you need a proprietary plugin in order to uncompress it and use the data. So from someone who has a definite slant towards the open side of things, I don't tend to use ECW so much. And then another one that we might see is something called NetCDF, which is a type of hierarchical data structure. I've come across that in various different guises over the years, and there's quite a lot around the meteorological and oceanographic side of things, so sea surface temperatures, both captured from satellites and also in situ. I've seen information wrapped up in a NetCDF format and then distributed that way. So I would say those are probably the main actual data formats themselves, although I guess someone will no doubt let me know if there's any others that are being used a lot. But so OGC Web Services, so that's the Open Geospatial Consortium. These web services are quite interesting, and they're becoming used more and more because as we get more data, and we've talked about there being data providers, well, there's also platforms for processing. And there's three main web services that I want to mention here. So there's web map services, which effectively takes a picture of the image that you're interested in. So let's say it's a satellite image. Let's change and say it's Landsat. So it'd be a Landsat image of, say, Denmark. And you can make a web map service request, and you get back a picture of that image. So it's like a snapshot. If you then wanted to pull the data down into something like, say, QGIS or ArcGIS, you can make what's called a web coverage service request, and that pulls the actual raster data itself. And there are reasons why you would do that, and it might be useful for a given process that you're looking at. But what we're seeing more of a little bit at the moment is something called web processing services. So I've only started coming across these in the last couple of years. So I think over the next few years, maybe these will become more and more important. But this is where you would upload effectively a little recipe to a server, and then the data would get processed on the server and you get back your answer, and it's the answer that you download. So I think these are more, or have been more common in the sort of vector GIS side of things. in recent years, but I'm seeing more and more Earth observation, remote sensing data being used in this way, because we're just getting so much data that really it's no longer useful in terms of downloading lots and lots of information to a local site. You want to be able to process the data where it sits and then just get the answer back. And there are lots and lots of different ways you can do that with, you can have Python instances on virtual machines next to the data and things like that. But web processing services is one other way of doing that.
So web processing service, this is the idea of moving the code to the data, the recipe to the data, as opposed to moving the data to the code, to where it's going to be processed.
Yes, it's one of the methods of doing that. Yeah.
So I personally think this is really exciting. Web processing services, I like the idea. And for me, anyway, the cloud optimized GeoTIFF sits on the other side of the fence. So that's an effective way, or it seems like a really, really efficient way of moving large amounts of data, or at least segmenting that data and taking just what you want out of it and moving it down and processing it locally. And I think web processing services, the other side for me anyway, okay, pushing the code over there. But the tension there for me is who pays for the compute?
Yeah, which is a very good point. Almost really what we've been talking about in terms of the data formats and the web services is at its sort of lowest level. And what we tend to see these days as well is a whole host of environments that are being built on top of this. So they will interact with data in a cloud optimized GeoTIFF, or they might use OGC web services themselves, but the user would log into an account and they would do whatever processing they want through their web browser, or they would use a Python or some other form of API in order to do that. And they might not necessarily interact with these different standards and these different formats at a very low level. But yeah, your question of then who pays for that? Well, if it's a system that you've logged into an account and that's a commercial system, that's fine. You're paying for it. There are different ways that requester can pay for data that they download off of things like Amazon Web Services or Microsoft Azure, and that has happened in some instances. Other models do exist, but it's very difficult to know, because this is one thing I think probably over the 20 odd years that I've been working in geospatial, it has been, how do we actually monetize any of these things? Is it per click? Is it per download? Do the data processors pay for it as a service and then people subscribe to that? Or do the people who want the data pay for it and through their subscription? There's a whole host of different ways of thinking about this, and I'm not really sure if it's something that's been answered that successfully.
Alistair, I'm really aware of the time. It's marching on. But before I let you go, I've just got one final question. And for me, this is a really exciting question in terms of Earth observation. So it feels, or I should say, in previous conversations with other people in the field, there's time and time again that this idea of subscribing to objects rather than data sets keeps coming up. And I guess this ties in nicely with these data that we're talking about, and how we get the data, how we access it. And what we've been talking about up until now anyway is just accessing what I guess you could call the raw data, although I'm aware it's been processed just by the fact that it's in one of these file formats, but we're still accessing the data. And this idea of subscribing to objects instead of data sets is that, just show me all the cars in that image, please. Is that the correct way of understanding it?
Yeah, I think so. So there's different ways of looking at it. So you can either have a parameter that you want to subscribe to. So it could be, I don't know, yeah, show me all the cars, and then every day you get an update in the number of cars that are in a car park or whatever. Or another one is you can subscribe to a set area, so an area of interest or multiple areas of interest. So that could be, have any new houses been built on this greenbelt piece of land, something like that. And then you would only get an update sent through to you when your rule has been triggered. So yes, a new house has been built. Send a message saying you want to check out the imagery. So that's, I would say those two things are definitely some interesting ways in which data dissemination is going to be used, because 9 times out of 10, I would imagine most users of the data, if they're not inside the geospatial realm like we are, most users just want the answer to whatever it is that they're trying to find an answer to, rather than being, they're not going to want to look at imagery unnecessarily and then download it and process it and everything else. So even if that's automated or semi-automated, what they want to do is subscribe to something that tells them, yes, the thing you're interested in has changed or has been updated or has disappeared or whatever it is.
Is there anybody out there at the moment that's doing this really well? Is there like an example of a subscription service like this that we could go and check out?
There are companies that do it, but I don't have a subscription to it, so I wouldn't know how well they're doing it. So I wouldn't want to say at this point about who those might be, because I mean, I'm guessing they're doing it. They certainly seem to be leading the field, but I would prefer to have direct experience of what these subscription services would be like, I think, before commenting on whether it's working well or not.
So on that note, I want to say thank you so much for taking the time to talk to me today. I've really appreciated it. I've also really appreciated your patience walking us through the definitions of remote sensing, where these, or what platforms are out there generating data, how they're generating it, what the difference are between the platforms, how we find data, and yeah, all the other things we've talked about today. Much appreciated. Really enjoyed the conversation. Where can the listeners go if they want to reach out to you or learn more?
The two obvious places would be either my website, which is jogger.co.uk, so it's geoger.co.uk, or you can also find me at Seen From Above podcast, so that's seenfromabove.org, or on Twitter, and you can use the hashtag Seen From Above, or I'm AJG Jogger, Geoger. Yeah, thank you very much, Daniel, for having me back on this. It's been really enjoyable to talk about different aspects of Earth observation.
It's been my pleasure. Thanks again. Thanks once again to our sponsor, GraphHopper. I really appreciate your support. It's fantastic having a company like you behind us. It's much appreciated. To the listeners, if you're looking to solve the traveling salesman problem, or if you're looking to do anything with routing optimization for larger fleets of vehicles, check out GraphHopper.com. You can support the podcast by supporting them. Thank you. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I want to say thank you for tuning in again this week. Much appreciated. I also want to thank the people that have taken the time to reach out to me on social media, find me on LinkedIn, to engage, to give their feedback about the podcast. It really helps me figure out what direction to take things in, to find out what you're interested in, what you're less interested in, how I can improve this for you. So your support, your comments, and your engagement is really, really appreciated. Thank you very much. Talk to you again next week. Bye.